All right, so I'm recording this on November 9th, and it just occurred to me that this will be watched after Thanksgiving. So maybe if you celebrate Christmas, you have your Christmas trees up, which is crazy. So this is Oligopoly. I am very confused by your textbook. I've taught this class many, many times with another book, and they cover one oligopoly model. Because if it's geared toward managers, why do you need high-level oligopoly theory? I cannot figure out why your textbook authors, they put 3 market systems in chapter 8, and then they have 2 chapters just for oligopoly. And my only suspicion is maybe that's like their field, and maybe they made one of the models. Whatever. What we're going to do is we're going to cover the kinked demand curve model, which they call the Swazi model, I think. Sweezy. And then what I've decided to do is actually teach game theory, which is something I haven't done in many, many years. Now, the reason I'm doing that, that's in chapter 10, is because if I think about your audiences, they are not going to care about the Corno oligopoly model. Game theory is super cool though, right? And that's actually like what happens at the leading edge of micro today. And so I thought that's just a better use of our time. So we're going to do part of chapter 9 today, part of chapter 10, and then for our last week of classes, I'm going to cover price discrimination, and depending on how we feel, and like if I get feedback, we could do a little more game theory, but we will see. We will see what we end up doing. So an oligopoly, it's a market structure that's characterized by only a few firms, each of which is large relative to the total industry. Your book says typically it's between 2 and 10. I don't know where they get that. Products can be identical or differentiated. For example, Coke and Pepsi, we can kind of call those a duopoly. And you know, Coke or Pepsi drinkers are like very concerned with them being different. But oil is also an oligopoly market, and that's basically identical, although there's different grades. So an oligopoly market of 2 firms is a duopoly. I just used that word with Coke and Pepsi. And oligopoly settings are the most difficult to manage because they have to consider the impact of their decisions on the decisions of other firms in the market. So if I'm running a coffee shop in Valpo and I think, oh, do I want to like raise my prices on this drink? I don't really have to think, well, then they're going to raise their prices and then, right? So because there's just so many firms and there's so little market power and monopolistic competition, you just don't usually have to worry about that. So I just threw this in here as a review. Examples are airlines. Difficult to enter this market, not very many airline players. I just bought tickets to New Orleans, and we found the tickets on United, and I thought, let's go over to Southwest and see if it's the same price. Yes, it was, right? They were watching each other. Cell phone providers, of course, and then oil. And the oil market's interesting because it's a cartel. OPEC is a cartel, which controls a lot of the oil market. So your book initially introduces this double demand curve here, but it does so in kind of a different way. So basically, if firms in an oligopoly are producing the quantity of Q0 and charging P0, whether or not your competitors copy price changes, it will dictate which demand curve you land on. So for example, if you raise your prices and the other firms are like, ooh, sweet, I'm going to raise my prices too, then what happens is you go to this inelastic demand curve. Now in this case, that would be great, right? Because you want to have the inelastic demand curve if you raise prices. In this case, if the rivals do not match your price changes, that would be an elastic demand curve. So you're the only one who drops your prices. Awesome, right? You get a really high response from your consumers. That would be the elastic demand curve. Unfortunately, with the model that I'm going to teach you, the kink demand curve model, the opposite is true. It's the bad. So it's going to be the elastic up here and the inelastic down here. I never knew it was called a Sweezy model. I had learned something new today. I always called this the kink demand curve model. So the Sweezy model, this is the only one we're covering from chapter 9. It's based on a very specific assumption regarding how other firms will respond to price increases and price cuts. All right, so here are the characteristics. There's a few firms in the market serving many consumers. Okay, that's an oligopoly. They produce differentiated products, okay? Each firm believes its rivals will cut their prices in response to a price reduction, but will not raise their prices in response to a price increase, and then barriers to entry exist. So this is actually from my other textbook. Your textbook provides one very confusing graph, and I just found that to be kind of difficult. So it's like the counterpoint to what I just showed you, right? It's the inside demand curves. So if you're, in this case, P and Q, right? So you're producing Q at the price of P. And you decide to drop your price. Everyone else is going to be like, oh, I'm dropping my price too. And in fact, your textbook has this nice example of Coke and Pepsi in India. I think it's in chapter 10. And one of them dropped its prices, so the other one was like, well, we got to drop our prices now, right? So what's going to happen is you're dropping your prices, and then demand becomes inelastic. Now, if we think back to chapter 3, that's bad. If you drop your prices and the good is inelastic, you're going to reduce total revenue. It's like, why would I put my cigarettes on sale? Okay? And then if you raise your prices, that's also bad because it becomes elastic. And again, why would you raise your prices on an elastic good? Everyone's going to get your competitors. So let's think about, like, you've got a few gas stations. You've got like 3 gas stations on 3 corners right by each other. If you drop your prices because you think you're going to get the whole market then, right? Everyone's going to stop at your gas station. Your competitors are going to do the same. So that becomes inelastic. If you raise your prices, the other competitors are like, sweet, we'll get all your business, right? They're not going to raise their prices. So that is where we get the kinked demand curve. So because marginal revenue depends on demand, we get a really funny looking marginal revenue curve here. So again, if this is our demand curve, we've got this kinked demand curve where it's elastic here and inelastic here. So what's going to happen is your marginal revenue is going to go from here, drop down, and then go to here. It's called a squeezy demand. All right. Wow. That's very confusing. No, okay. So your marginal revenue curve is this red one. Whoa. Okay, so it's based on this elastic demand, drops down, and then it's based on the inelastic demand. So one thing that I've done is I actually copied this other textbook I'm using because I just think it's a nicer graph. So I've also posted this. You've got the kinked demand curve, and then the marginal revenue drops down and goes over here. So going back to our PowerPoint, if firms produce where marginal revenue equals marginal cost and then go up to the demand curve to get the price, as like monopolies do and monopolistic competitions do, you got this funny marginal revenue curve. So if we've got marginal cost here, okay, marginal cost crosses marginal revenue, that's how many you produce, you charge price B. If your marginal costs drop, okay, what's going to happen is you're still crossing marginal revenue at Q0 and you're still going to charge P0. So you've got this thing where it's a really big range where even if your marginal costs change, you don't change the price or quantity. And that's a feature of oligopolies, right? Like think about Coke and Pepsi. If the price of high fructose corn syrup or whatever it is they use goes up, they're probably not going to be like changing their prices or changing their quantity. And so I think this is an interesting outcome. Now let's look at it in the clearer graph here. Again, this is demand, this is marginal revenue. In this case, marginal cost here, you're going to produce at this quantity, you're going to charge A. Marginal cost increase, still produce at the same quantity, still charge A. So that's the only thing that we're covering in oligopoly. It's not super easy. So what I've decided to do is on this homework, I've decided to give you 3 tries. I think there's only 3 oligopoly questions. I've decided to give you 3 tries because it's not super easy. I would actually recommend reading the book. This is the Squeezy model because it's just, you have to have a handle on elasticity, and some of us don't think about that all the time. So with that said, I'm going to move on to game theory. So let's see here. All right. So game theory. So when we think about like what modern day microeconomists are doing, um, they're not like perfecting supply and demand. Most economists actually use statistics. They're not theoretical people anyway, but even theoretical people, they're not like refining neoclassical economics. What they're doing is either creating new theories. So for example, I cited a paper in one of my papers where this guy had a theory of wearing veils. So in like Muslim religious societies, women are more likely to wear veils now than they used to be. And so he had this whole theory where it was like a way to mask the fact that you're secretly getting educated. I don't know. That's like a micro model today. The other micro models, which comes from a field called industrial organization, are all based upon game theory. And it's really cool. So when I was in my PhD program, the first half of the year was neoclassical micro. Hated producer theory, which is funny because I like teaching it now. Loved consumer theory. And then I got to my game theory class and I was like, this is so cool. And at one point I thought I was going to go into it. Part of my dissertation, actually, I do extend a model of game theory. But we're going to go through it today. So game theory is a general framework to aid decision making when agents' payoffs depend on the actions taken by other players. And games consist of the following components: players or agents, planned actions, which is a strategy, the payoff of players under different strategies, a description of the order of play, a description of the frequency of play or interaction. So like back when I was learning these things, you'd always have to state these assumptions on the board. There's one stage, you do it simultaneously, there's how many players, things like this. All right. All right, so just to define a few things, there's two types of games. One is a simultaneous move game and the other is a sequential move game. Simultaneous move game, each player makes decisions without the knowledge of the other player's decisions, and then you like reveal your preferences. Your book talks about the Bertrand duopoly game. I didn't teach you that. Paper, rock, scissors, right? I just played this with my son. He's 4. He comes home. He's like, Mama, I want to play paper, rock, scissors. I didn't know he knew how to play this, right? Paper, rock, scissors, and then you reveal it. It's really hard to get you, like I try to let him win. It's hard to let him win with that game. The other is a sequential move game. This is where one player makes a move after observing the other player's move. So this would be like tic-tac-toe, right? You played an X here, so I'm going to play an O here. All right, then we've got the different frequencies. A one-shot game is it's played only once. This would be rock, paper, scissors again. A repeated game is where the underlying game is played more than once. This might be like 2 gas stations on either side of the street. You have a homework question like this. One of them drops its price, the other one drops the price, then the other one, then the other one. That would be a repeated game. So a strategy is a decision rule that describes the actions a player will take at each decision point. We know what a strategy is. A normal form game is a representation of the game indicating the players, their possible strategies, and the payoffs resulting from alternative strategies. This is a normal form game, okay? So we've got 2 players, player A and player B. Player A has 2 strategies, up and down. Player B can go left or right. And your book makes a big deal, like we're choosing a general thing, because you could think this is company A, company B, raising prices, lowering prices, raising prices, lowering prices. It fits with a lot of things. So it probably is a good idea now, I'm going to stop and start a new recording, for you to try and think about if you were player A, what you would do.